All right. Good morning, everyone. Let's start the class
Good morning,
today.
sir.
Good morning. Okay. So today we're going to start something new, something different, something very important, right? And can you guess what we're going to start today? Anyone? Okay. So today we are going to start something which is very important to C programming, and I'm going to introduce to you the concept of pointers. Okay. Now, this is one of the most important concepts in C programming. So it's very important for us to understand it well. Okay. So you've learned so many, concepts in the past. You have learned about the C data types. You've learned about the operators. You have learned about, some of the functions. You have used printf, right? So in this lesson, in this particular chapter, I will introduce you to one of the most important and powerful feature in C. Okay, and that is called as pointers. All right. So we will look at various topics under this chapter of pointers. We will look at what exactly is a pointer variable, but before we understand pointers and we understand pointer variables and you know the different things associated with pointers, we need to understand a little bit about memory. Okay. So let's discuss a little bit about what exactly is memory, what exactly happens with a program, and how things are actually stored. Okay, before we move on to pointers. Okay, so when you declare a variable, so when you write something like int x, okay, now this int x is basically we are talking about a container. We are talking about a container which basically has a name x, right? And this container is going to store a value. So when I do x is equal to 5, this value 5 is going to get stored. Now the question is, in the program, when you run the program, we're running it on a computer, right? And when you're running it on a computer, I told you that there are a lot of components which are actually helping us execute a program. So we have the compiler, which is actually helping us process the code. Then finally we have the linker and the loader. So when you execute a program, the program is basically taken to the RAM, right? It's basically processed in the RAM, isn't it? All of you know what's a RAM, right? Is RAM a permanent storage or a temporary storage? Okay,
Temporary
very good.
storage.
So RAM is a temporary storage. That means when we talk about something called as a storage, that means it is like your cabinet, right? It is like a cabinet, right? Where you can store things. Now, if you have a cupboard at home, that is also a storage area, right? So what do? You store some stuff here, you store some stuff here. So basically, this is how you store your things in a cabinet. Now, RAM is also a place where a lot of things are stored. So you can store data, you can store the code, right? And what exactly happens is there is something called as a processor. All of you know that we talk about a processor. Processors is basically the part of your computer system where all the processing happens, right? Processor. Now, what exactly happens in the processor is this is basically your brain, right? All the processing is done here. Now, in order to process, we need instructions, right? So we need instructions, and instructions will work on the data. So what happens is the processor is connected with this storage, that is RAM. It is connected. So there is a small amount of memory in the processor also. Okay, there is a small amount of memory in the processor also, because if you go and buy a computer, you will definitely, when you look at the specification, they will talk to you about a processor, and the processor is either a 16-bit processor or a 32-bit processor or a 64-bit processor. So you must have heard about these three terms, right? that the processor is of 16-bit or 32-bit or 64-bit. Now you know what's a bit, right? So if you have a 2-bit processor, that means the processor has a memory capability of only 2 bits, right? If you have a 16-bit processor, that means your processor has got a memory of 16 bits. Similarly, 32 bits will be double of 16 bits. Nowadays, we have everything which is 64 bits, right? All our computers are 64-bit processors. So 64-bit processors means the storage capacity inside the processor is higher than 32 bits. So you have 62 bits. Now, why do we need a storage of 64 bits or 32 bits inside your processor? Because this is like a container. So the memory which is present inside the processor is like a container. So basically what happens is, suppose in the RAM, you have stored different instructions. Okay, you have stored different instructions. So what happens is the instructions are executed one after the other. So how is it executed one after the other? This first instruction is loaded into the processor, right? So this instruction is loaded into the processor and it is executed. So when it is loaded into the processor, you need a container inside a processor to hold that particular line of code, right? So that line of code is actually stored inside this memory. If it is a 64-bit processor, then it will, store a 64-bit, it can store a 64-bit long instruction or a code. Okay, along with this particular line of code that you're storing inside a processor also needs some data which needs to be manipulated, right? So suppose if you're adding a plus b, right? Now this is, you are giving the instruction to add two numbers a plus b. So along with the instruction that you send to the processor here, you also must send the two values a and b. So a and b are taken from the RAM and it is also sent along with the instruction. And what this instruction is done is the execution happens in the processor. The processor executes or processes that line of instruction, and then it returns the value, the 2 plus 2. Suppose a value is 2 and b value is 3, it will return the value 5, and it will return the value 5 back into your RAM. Okay, so 5 will be stored somewhere into the RAM. So because the size of the memory inside a processor is small, that means it's only 64-bit. Given the latest processors or latest processors that are available in the market is 64-bit processors, at the max, it is capable of processing 64-bit instructions. That means there has to be a match. So if you have a program, say suppose I have a C compiler or a C program, right? And if your C compiler is able to process 64-bit instructions, then your computer, which is of 64-bit, will also be able to process this entire 64-bit. So if you have a processor of 32-bit, but if your compiler is if your compiler is generating 64-bit of your instruction, then there will be a problem. Then this processor will not be able to handle this particular compiler, right? So if you have a processor of 64-bit, it is able to process 64-bit instructions, 32-bit instructions, 16-bit instructions. So any instructions which is less than 64-bit can be handled by this processor. But if you have a processor of 32-bit, you cannot handle instructions which are of 64-bit. Okay, so what exactly is the significance of this? That means if you're buying a software, if you're buying an application, if you're installing a software, and if the software is a 32-bit software, so if you download any software from the internet, you will find that there are different versions. One will be 32-bit, one will be 64-bit, right? One will be 16-bit softwares. So the software, it will ask you that what operating system and what machine do you have. So according, you have to download the version of the software. So when you download a 62-bit software, it means that that software can generate a instruction which is of the size 32-bit. What do I mean by an instruction which is of the size 32-bit? I'm going to give you an example. Now, let me give you an instruction. Okay, suppose any one of you is a processor, and I am a software which is going to execute, or which is going to give you some instructions. So my instruction is like, let's say, go to the living room, right? Go to the living room and get the TV remote. Okay, suppose this is my instruction that I'm giving to you. So what is the instruction? The instruction is go to the living room and get the TV remote. Now, only if you have the capability, or if you have the size of memory to store the entire instruction, you will execute. But imagine that your memory in your brain is not able to handle such a large instruction. So what will happen? You will not be able to carry out my instruction. So you will only get half of the instruction, like go to the living room and then your memory is full. Then the second part of the instruction you will not be able to execute. So this entire program, or the entire instructions will fail. What means is, that means that you have a 16-bit processor, but the software which is generating this instruction is generating a 32-bit instruction. So there is a compatibility issue, right? So what I should do? So I should get a software which is also of 16-bit instruction size. Now, how does this software of 16-bit instruction size give the same instruction? So what it will do is, now it will give you only a 16-bit instruction. That means what I will tell you is, first instruction, go to the room. Okay, you execute that instruction. Now the second instruction will come, get the TV remote. Okay, so the same instruction which I was giving you once, now I am giving you in two parts. In the first instance, I told you go to the room and get the TV remote. So that is a long instruction I'm sending you at once. Because you are 32-bit, I'm giving you 32-bit instructions, you will easily execute that instruction. But in the second instance, because you are 16-bit and I am 16-bit, that means I cannot create a long instruction. So I have to give you instructions in short. So what I will tell you, go to the room. So first part done. After that, you will go to the room, and then I'll give you the second instruction, get the remote. Okay, then you'll get the remote and come. So why am I telling you all this? Because memory is very important. Okay, and in all this that we have actually discussed right now, right, we are talking about the memory. So if you are buying a 64-bit machine, if you're buying a computer, a processor which has a 64-bit capability, right, but all your programs and the software are capable of only 32-bit instructions, that means you are wasting money on a 64-bit processor. Okay, so what you should do, you are basically using 64-bit processor, but the processing of instructions is happening only at 32-bit. So there was no need for you to buy a 64-bit processor. You would have bought a 32-bit processor for a lower price, and there will be no change in the processing speed. Okay, so it's very important to check what you are buying, and it's also check how, for example, all of us go and buy, like when we have a chance to buy memory, we go and buy 4 TB, 2 TB, right, 2 TB of memory. But you will notice that over a period of time, when you're using the hard drive, or when you're using the external hard drive, you will not be using 4 TB at all. At the max, your hard drive will be 2. You'll have 1.2 TB of space. So if you notice, you are wasting around 2.8 TB of space. So a 2.8 TB hard drive cost would have been saved if you had gone and bought a 2 TB hard drive, right? So it's very important to check the memory specifications before you actually buy anything. So how does memory come into the programming? Okay, so how is memory important in programming? So now let me give you an example of how we talk about the memory in a program. So you know that RAM, right? So RAM basically needs RAM will have a memory location. So when I write integer A, the compiler will need a storage. It will need some memory in your storage area. So what it does is it reserves a storage area of, say, if integer is 4 bytes or 2 bytes, whatever the compiler allocates, because it depends on the specification of the compiler. So if the compiler allocates 2 bytes for an integer, then 2 bytes of memory will be reserved in the RAM for you. Okay, so suppose each of these cells are of 2 bytes each. So all these are 2 bytes. Then if I write int a, then what the compiler will do is the compiler will go and allocate one memory of 2 bytes into the RAM. So suppose I write int b, that means another space for 2 bytes will be allocated in the RAM. Now suppose I write float c. Now if float has 4 bytes, that means these entire 2 blocks, right? This and this will be allocated for this c, right? Similarly, if I have, say, character d, that means if character is of 1 byte, then you will have only 1 byte allocated in the RAM. Are getting it? So in the RAM, what happens is your memory is basically divided, the space is divided in different bits, byte 1 byte. Okay, now depending on how you actually allocate your data, allocate your variables, your memory is actually allocated in that way, or it is reserved in that sequence in your RAM. So did you understand till now whatever I have told you? Have you understood?
Yes, sir.
Okay. Now the fun part starts. Okay, now the fun part starts. So if you have a memory location like this, right? So if you have a memory location like this, and if your compiler is allocating space, so suppose A has been given this space, B has been given this space, C has been given this space, and D has been given this space. Okay, now A, B, C, D are usernames. They are just our names, right? The names that we are giving in the compiler. But the compiler doesn't understand A, B, C, D. That means you don't, when you go inside the RAM, you will not find A, B, C, D written there, or you will not find that there are some numbering done here. But what is actually happening here is all this, the memory spaces which are actually allocated have their address, that means each of these cells have their own address. Just imagine that if you are actually all of us have our houses, right? All of us are in this entire planet, there are millions and billions of houses. Now think about, let's take an example of this earth as a RAM. Okay, if earth is a RAM, then there are lots of memory locations on the earth, and these memory locations are our houses, because that's where we are storing ourselves, we are storing our things, everything we are storing inside a house. So all of us are staying in a house, and this is a part of your memory location. Okay, now each house, that means every house on this planet also has an address. Yeah, every house, your address will be different from mine, my address will be different from yours. Now because of this address, I can basically access any memory location or any house on this planet. So if I want to send a letter to you, I need an address. So if I have your address, I can reach your memory location, I can reach your house, I can make changes inside your house, I can, go to your house and do some kind of stuff, I can get something from your house, or I can go and give you a gift, and that gift will become a part of your house. So if the addresses were not available, right, then we would face a problem. Then the second way of finding out would be through the names. Just imagine if there are 10 people sitting inside a classroom, right? I have to remember the names of all the 10 people in order to access them. But imagine a scenario that if I have around 1,000 people inside a hall, and if I need to access someone from there, that 1,000 person, that 1,000, the crowd of 1,000 people, it's difficult for me to remember the names of all the 1,000 people. But what is the easier way of getting to a person. The easiest way of getting to a person is by finding out the address where he is seated. So I can say that, okay, I suppose you're seated in a row and column. I can say, so for example, let's take an example. So suppose this is a hall and the people are seated in a sequence. So these are all the chairs. So there's a one guy who's seated here and I need to reach to him, right? Now it's impossible for me to know the names of all the people. So how do I reach to him? How will I ask him a question? So one way of asking a question to him would be, if I know his name, I can say, Peter, can you stand up and tell me, what do you think about whatever question I have? So he will stand up. But now it's very difficult for me to remember the names of all the people in the audience. So what will I do? I will start using the address to access him. How will I, use the address? Now I will tell him, so suppose this is one column, second column, third column, and suppose we start from here. So this value will be 1 comma 1, this value will be 1 comma 2, this value will be 1 comma 3, this will be 2 comma 1, 2 comma 2, 2 comma 3, this will be 3 comma 1, 3 comma 2. Now 3 comma 2, basically this 3 is nothing but the row and 2 is nothing but the column. So I will say the person who is sitting on the third row, the second column, please can you stand up? So who is sitting in the third row in the second column? This guy, right? Now without knowing his name, I will be able to access this person here just by using the address of this memory. Okay, what is the address here? The address is 3 comma 2. Now there is another way of actually doing the address. Now here the addressing I have done is I have used two numbers, 3 comma 2, which is row and column. But imagine if I have a, if I do the addressing using one number, say I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So if my addressing is based on 21, I can say the person sitting at, the number 8, please can you stand up? So 8 is going to be the address, right? So it is very difficult for the compiler to remember the names of all the variables. Okay, just like it is difficult for us to remember the names of all the people. So what the compiler does is it remembers where it has stored the value of A, B, C, D in the memory by keeping track of the addresses. Okay, by keeping track of the addresses. So every memory location has got an address. Okay, and when you store a value inside that address, right, that value is basically, what we do is we give a user friendly name, A is a name which is easy for us to understand, right? But the compiler understands or remembers where the value of A is by an address. So every location in memory will have another number. Okay, and that number is basically an address. Okay, now why did I tell you this entire story about the address? I told you the entire story about the address is because the next chapter that we're going to start, or we have already started, is pointers, and pointers work on addresses. Okay, so till now you have only dealt with variables directly by assigning values to them. But we are going to introduce a new concept. Okay, the new concept which is called as indirection. Okay, we are going to introduce a new concept called as indirection. In this, instead of assigning the values directly to variables, you can indirectly manipulate a variable by creating another variable called as a pointer. Okay, we can indirectly manipulate a variable by creating another variable, and that variable is called as a pointer. It's a special kind of variable. It is not an ordinary variable. It's a special kind of variable. What is so special about this variable? Now this is a variable. So for example, if I write int a is an ordinary variable. Okay, A is an ordinary variable. What does A store? A stores an integer value. So I can store the value 5 inside A, I can store the value 10. All these are integers, right? But I have a special variable. Now that special variable can be B. Now since this is special, right, it is not an ordinary variable. I have to actually, give it a symbol. I have to, differentiate it from an ordinary variable. So how do I differentiate it? I will differentiate it by writing a star. Okay, I will write a star. Now by star, we whenever we want to differentiate, we put a star. And star means, like in normal terms also, when we say, oh, he's a star performer, that means he's special. So this is a special variable. This is an ordinary variable. This is a special variable. This variable is called as a pointer variable. Okay, this variable is called as a pointer variable. So if I declare int x, this is an ordinary variable which is going to store an integer. But if I declare an int y, this is not an ordinary variable and it is not going to store an integer. Okay, now what exactly will this pointer variable store? Okay, now this pointer variable will store the memory address of another variable. So that means if I have a, suppose this is my RAM, and if I have a which I am say storing value 5. Now if you look at this a, this is a variable where an integer can be stored. Along with this integer, it will have another value. It will have another value. What is that value? Another value will be associated with A, and that value will be the address of this memory location. That means it could be a number. Let's say 1111. So suppose this is 1113. Suppose this is 1115. Okay. Now these are the addresses of these memory location. Okay, so when I talk about the variable a, there will be two values which will be associated with a. One value will be the value that we are storing, and the other value is the value of the address of this memory location. Okay, now when I talk about int a, this is going to store this value. And when I talk about a pointer variable, or when I talk about the special variable, which is also called as a pointer variable, this pointer variable will store the value of this. That means you cannot store this 5 in here. You cannot store. What you can store in this special variable, you can store the memory address of another variable. So inside this pointer variable, I can store this number. This number, what is this number? This is the memory address of variable A. Did you understand? Anybody has a doubt here?
No, sir. Sir,
Okay. Because yes,
sir, when we use pointer, it basically define the addresses of
yes.
the particular value where it resides. Like if you, sir, is it problem if you use array instead of pointer?
No, no, array,
Since
array.
it, yes, sir,
No, no,
like
array,
index
array.
number.
Yeah, yeah. We will talk about array later because we have not touched. I will introduce you to array, and there I will show you what is the relation between pointers and arrays. I am asking, have you understood whatever I have explained as of now? Because arrays will come as a next concept, and I will connect the pointer and array that time. Let's not get ahead of the class. So, because a lot of people are there who are doing programming for the first time, so it's important for them to understand these concepts and then move slowly ahead. I will, after pointers, I will get arrays into the picture, and then we'll connect the pointers and arrays together. Okay, but for now, whatever I have
So
explained, I hope
pointers are always
everybody's
defined by
understood.
int.
Not really. Pointers are not always defined by integers. You can have different data types also here. What I have given you is a simple example. Now I'll explain to you exactly what does int or different data type mean. But for now, all you need to remember is when I declare a pointer with a star, that means this pointer variable will not be storing an integer. It will not be storing a number. It will be storing the address. Okay, so that's important right now, and then we will move to the next part of it. So till now, everybody is okay?
Yes, sir. Clear.
Okay, fine.
Yes, sir.
Yes, sir.
Okay, fine. So, for starters, for someone who is just starting with programming, using the memory address of your data is often the quickest and the simplest way to access it. There are so many things that are difficult, right? I know it's a little bit confusing when you start doing things with pointers. At one point of time, you will, there'll be some confusion in your mind. But once we get the concept clear, we are actually it's going to be very, very clear. Okay, so basically, we'll not get into arrays right now. I will actually discuss what's an array, and then we will get into the array and all that stuff. So two things that you must remember now. From the definition of a pointer, you must remember two things. First, that pointer is a variable. Okay, pointer is a variable. That's the first important thing. Now, because it's a variable, I can assign different values to it. Okay, because it's a variable, I can assign different values to it. Okay, I can assign different values to it because it's a variable. All right. And the second important thing that you must remember is that the value which is going to be assigned to this variable should be an address that will indicate the location of another variable in the memory. All right. So the second point, important point, just listen to this carefully, that the value that you're going to assign to the pointer should be an address that indicates the location of another variable in the memory. So let me just make things clear here. So suppose I have an integer x. Okay, suppose I have an integer x. So this is my memory location, right? This is my memory allocation. I'm just giving some simple numbers here. Now the memory address, say this is 101, say this is 102, 103, 104. So suppose this is the address. These are the address of the memory location. All right. Okay. So let me just remove this. Okay. So these are the address of the memory location. So now when I do int x, that means the compiler is going to allocate some space in the memory. So let's assume that the compiler allocates this space in the memory. Okay, so this is the space which the compiler allocates for x. Okay, now let me write another line. Let's say x is equal to 4. So when I write x is equal to 4, the compiler is going to take this 4 and it is going to insert this value 4 inside the memory location in which was allocated for x. All right, this is fine. So now if you see, there are two numbers associated here. One is the actual number 4 and the other one is the number 103. Now 103 is the address. Okay, so now if I declare another pointer variable, say if I declare a pointer variable p, now I have to, when I declare this pointer variable p, I have to put this star in front of this. This star indicates that this variable is not any normal ordinary variable which is going to store an integer value, but it indicates that this is a special pointer variable. So what this pointer variable can store, if I write 5, it is incorrect because this pointer variable cannot store any normal integer. So what can this pointer variable store? Now this pointer variable, I can assign the value here, this value. So inside this pointer variable, I can assign 103. Why 103? Because 103 is the address. So these are the address and these are the actual values that are being stored inside these. Okay, so a pointer variable is a special variable. So there are 2 points that I discussed. So from the definition of a pointer, you must know 2 important things. First, that pointer is a variable. Because it's a variable, I can assign values to it. Okay, that's an important point. And the second point is that the value that you're going to assign into a pointer variable must be the address. Okay, must be the address of another location of another variable. That means it must be the address of another variable. So this, for this P, there will be another, say 106. So when I write int P, the compiler will do an allocation for P because the P is going to store some value. So this, say compiler suppose allocates this value. Okay, so for P, the compiler allocates this in the memory. Now when I what can P store? P can store an address of any addresses P can store. So in this example, if I am actually storing the address that is 103, so this will be the address which P is holding, and inside this P there will be a value, and that value will be 103. Okay, so for int X, a memory will be allocated. For int star P, a memory will be allocated. Okay, so when I do X is equal to 10, this 10 will be here. So for this P, what I can do, now this will have an address, say 105, this will also have an address 107. Now what I can do in P is I can store the address 107. So P will be pointing to this because I am storing the address in that. Did you understand this concept?
Yes, sir.
Yes.
Can you repeat
Can
it
I
again?
have some response? Did you understand what I explained here?
Sir, repeat please.
What I told you right now is the 2 properties of a pointer. That pointer is a variable. Because it's a variable, I can assign values in them. Second is the value that I'll be assigning to the pointer variable is not an ordinary value or an integer, but I will be assigning the address of another memory location, right? So in this P, I am assigning the address of another memory location. Now this is a very important concept, so I hope you are clear on this. If you have a doubt, I can explain it again, but let me know. Have you understood what I have explained to you so far?
Clear, sir.
Yes, sir.
Yes, sir.
Yes,
Are
sir.
you able to hear me?
Yes, sir. Yes, sir. Completely
Are you
clear, sir.
guys able to hear me?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yeah, I can't hear any.
Yes, sir.
I can't hear
Yes,
anyone.
sir. Yes, sir.
Yes, sir.
Hello.
Yes, sir.
All right. So, are you able to hear me? Did you understand?
Yes,
I
sir.
think I got locked out.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir. Completely clear. Can you hear us, sir?
Okay. Can you all give your attendance, please? Just write your roll number in the chat box. So let's close the class for today. I can't hear anybody, giving any responses. So let's stop the class today. You can go and watch this. I'll upload this video on YouTube today. So if you have a problem or if you're not able to follow, please go through the lecture again and I can explain it to you again in case you have a doubt. Okay, so all of you please give your attendance.